I'm Dave Hobbs for Delphi Product and Service Solutions, and thank you for watching this podcast called the Delphi Auto Parts Cast. And we've got Dave Kinney, an engineer in fuel systems, with us as our subject matter expert today. And we've got questions to ask him that you, as a technician or shop owner, are definitely going to want to keep watching and listening and learning, because I know I have, getting ready for this and kind of doing a little bit of interviewing with Dave beforehand. So let's get started. Dave, you're a car guy, and
Yes.
that's a unique thing in a lot of industry. You know, manufacturers like Delphi and all these people that are, you know, their background is software, mechanical, electrical engineering, and automobiles may be something that they've been forced to learn. But you've had this in your blood. Tell me about that.
Yeah, I started GMI, or it's called Caddy today, and went in to get my mechanical engineering degree. And a lot of the students back in the 1980s when I went to Caddy were car guys. They had Chevelles, I had a Nova, they had, you know, all the old 70s and 80s classics, and because we were starving college kids, we had to learn how to fix cars.
Yeah.
And so a lot of my friends were into Buicks, Chevys, and mostly GM, because I grew up in the Flint area, which was GM, born and bred. And I got into cars and bought a lot of used cars, and with my uncle and my stepfather learned how to diagnose cars, fix brakes. Got into some fuel pump issues at an early age with my first four-wheel drive truck. As you know, in Michigan, we have a lot of rust, a lot of salt.
Oh, yeah.
We lose fuel gauge all the time because of rusted out wiring, bad grounds, so that's how I got my start. And then I rolled into fuel systems engineering as I went through my GMI days and did a thesis on a control module for a brushless pump back in the late 1980s.
What a great background. And at Caddy University, I got to brag about the Delphi DNA, because Boss Caddy, also correctly Charles Franklin Caddy, invented the electric starter motor that became a huge sensation overnight in the early part of the 1900s, and went on with things like quick dry paint and distributors over magnetos, and right up through a lot of the technology that we take for granted today. Thanks to Mr. Caddy. So that's definitely in our DNA here at Delphi. And you're not just from the past, you're still a street rodder. You mentioned you have what kind of a...
I still have a 1986 Buick Grand National with the turbo V6.
Yeah.
Flint built, Buick V6 power. Still runs great, has 150,000 miles on it. It was the first car with two-port injection by General Motors, and I think it was one of the first cars with a serpentine belt.
Yeah, it was. Yeah. I had the non-turbo version in a Century, and it still would scat for that size of that engine and that horsepower to weight ratio. So there's a little bit of a key here. We're going to be in good hands today in this podcast, talking to a real car guy who's up to date, not only with what's going on in the streetcar world, but also what's going on in your tank, your customer's tank, when it comes to fuel pumps. So let's address a little bit about fuel pumps.
Sure.
There's a lot of issues with fuel pump returns. I remember at one time we had a fuel pump manufacturers council where a lot of auto fuel pump makers, Delphi and several others out there, we all kind of put our differences aside as competitors and work together to try to come up with education and the standards to try to reduce this huge warranty issue. And because it wasn't so much the pumps failing, it was things that were killing the pumps, almost like the old saying with catalytic converters. Catalytic converters typically do not die a natural death, they're murdered. Would you say the same thing about fuel pumps? A quality fuel pump, let's say a Delphi pump.
Correct. A lot of the pumps that I look at a lot of the DPSS aftermarket pumps that come in, and what I'm seeing is a lot of contamination, rust from filler necks falls into the tank, sand, stuff that's small enough to get through the strainer but gets into the pumping section, and a lot of misdiagnostics because of the wiring. Let's face it, in states like Michigan and the Rust Belt, you run into a lot of corrosion, bad grounds. One of the former coworkers and I went to visit a Delphi engineer that was running a shop in the Brighton area here in Michigan, and he had put 3 Delphi pumps and 1 Airtex pump in the same truck, couldn't get pressure out of it. We ran a redundant ground after we tested the pump just on a 12-volt power supply and seen that it was running just fine. When we ran the redundant ground, the truck started right up and it was a bad ground.
Yes.
The voltage drop test basically proved that it wasn't the pump, but he had went through 4 of them, and he was going to send 3 of them back as warranty.
Oh my! And this was an expert.
This was a
professional.
former fuel pump engineer that was running an outside shop on the side after he retired from Delphi. And Charlie Geit, our former trainer at Delphi here, who had a lot of experience, he had taught me a lot, because with a test light, it would show it was fine. But when you put that, I think 10 amps or
the
two
load circuit.
high beam headlight, basically amperage,
Substitute load.
you would actually see the pump would fall and it wouldn't generate enough power to fire the injectors.
Yeah, I want to come back to the electrical side in a minute, but you mentioned something that touched a nerve with me, because I'm a trainer, and I've had a lot of professional techs in class, and they talk about sand. They want to know, where does the sand come from? How does it get in the tank?
Well, what we're suspecting is, let's face it, when you take the fuel cap off, if you've ever noticed, like my Bonneville, I drive a 2000 Bonneville, they get a lot of dirt around that filler neck.
Yeah.
And then a lot of the newer evap systems after 2002, when they had the onboard vapor recovery and that, we're wondering if the purge solenoids maybe as they get older, are allowing stuff to get in the tank. But the big one I'm seeing, believe it or not, and especially on Chevy Silverados, is rust and stuff going down the filler neck. Even though you have a plastic tank that doesn't rust, the filler necks are metal. There's a lot of companies selling new filler necks like
Oh yeah, I'm sure a lot of you watch, and you put more than your share of filler necks, and if for nothing else, for evap code. So back to the electrical. Let's talk voltage drops. I find that voltage drop testing done the correct way, it almost seems to be an art that's never really caught on. I mean, everybody has their idea of what a voltage drop is, but you mentioned the load, the substitute load.
Right.
Would you say you can have a voltmeter connected between, let's say, the battery positive and the feed to the pump, with, let's say, the pump activated with your scan tool, you turn the relay on, whatever, and unless that pump's running and drawing some current, you're not going to see necessarily
just
a
like
voltage drop.
Even with the test light lights up with such a small milliamp of amperage that it won't show a fuel pump that's got a marginal ground or power side.
So if you can't hear the pump, or even suspect the pump's drawing way less current than it normally should, and I want to come back to that current topic in a moment, because that's kind of a third rail right now, but would you say that you really need to get a substitute load on this? Go out and draw, what, 10 amps?
10 amps is probably the best. The equivalent of 2 high beam headlights. Remember Paul Scherrer talked about using 2 high beam headlights in the series.
Right, yeah. So those are great ideas. A couple of halogen headlamps, you would want to put them in parallel, so that you're not really caring about how bright they are, but they're just there in place of the fuel pump itself. So the power in the ground that runs to the fuel pump, you're going to disconnect the fuel pump, and with some jumper wires, go from the harness that would plug into the pump across a couple of halogen headlights, not seal beam, but the small ones, in parallel. Therefore, you get about 10 amps. Go measure it with your amp clamp and see that's around 10 amps. And then look at the voltage between battery positive and the feed to those 2 halogen headlamps. And do the same with the ground side, the negative cable of the battery, or a known good chassis ground to that negative feed to that fuel pump. In this case, the substitute load for the fuel pump, the halogen headlamp, ground, and make sure you're not over, what, a half a volt?
I think it's a little less than a half.
Tenth of a volt per connection.
I think it's 0.25 was the number that comes to mind.
0.25.
I know we have a YouTube video on it on our Delphi website.
Got a video on doing voltage drops the correct way. So make sure you're doing that. Otherwise, you may be putting the second and third pump on and getting mad at the supplier, and you still haven't fixed the car. And it's really, in actuality, a connection issue. What percentage of the time would you say is connection issues? And are there any clues, looking at the pump itself, the connector in the pump, that tells us we might have connection issues?
Normally, the parts I get back, if I run them on my test stand and they flow to specification and I don't see a lot of contamination or any evidence that the pump was in a long time, I'm going to suspect, especially on some of the higher pressure Vortec engines, 5.3s that run higher pressures of 62 psi, I'm going to suspect you got a margin of ground, especially, or positive side.
Right.
That's causing the pump not to deliver the pressure to fire the injectors.
Yeah, let's talk about pressure versus volume. what would just a guess, a wild guess, a percentage of times out there where a pump fools us, where we put a pressure gauge out there on the rail, maybe we're blessed with a Schrader valve, or probably not, we're breaking into our fuel pressure test kit, and we're seeing a good number. Let's say it's supposed to be 46, and it's 48, it's 47 psi. So you think that's good, maybe it's a different drivability issue, or the pump's intermittent. How much of the time is the pressure okay, but the volume fades away under load?
Normally, if you have a pump that's delivering pressure but it's lacking volume, if you were to step on the accelerator and you don't see your fuel gauge go up a little bit, that'll tell you that you're losing it. Especially if it drops for a second, where it should go up just for a second and then come back down as you step on the accelerator.
That's kind of comparable to watching a vacuum gauge. You're doing something with the throttle, and you're looking for a reaction.
Right.
So if it drops and doesn't come back up, or just stays down,
if it stays there or drops, and it doesn't go up just for a second, you should see the gauge do this just a little bit.
So it should pop down a bit.
It should actually go up for a second and then come back.
Okay, what causes it to go up a little bit?
I believe it's the pump. As you step on the accelerator, you have the return line, or sometimes they're returnless, but they have a control module. I think what it does is the engine sees the TPS input and some of the other parameters and says, hey, I need more fuel. So it goes up for a split second, and then as the return fuel starts.
Makes sense. A reaction to the return line, or
correct.
In the case of the systems that use a pump driver module, a reaction to that as well. It's like an old accelerator pump and a carburetor.
Basically.
Guys our age, you remember this stuff, okay? Let's talk about corrosion and E85.
E85 is basically alcohol fuel, and what it tends to do is any moisture in the tank that can come from condensation from, if you leave your car at low fuel all the time, and you go through the heating and cooling like we get here in Michigan, where daytime high could be 70, but it might be 40 at night. Well, that water, if it builds up in the tank long enough, it's going to mix with the alcohol fuel, even the E10 that we buy at the gas pump, probably 95% of us. It's going to go to the bottom of the tank, and it's going to sit around that fuel pump, even in a module. And then you start to see pumps that come in corroded. They've got actually rust on the outside of the shell if it's long enough, or if they sit around for months at a time. Like some people, like I park my Grand National all winter. What I try to do is keep the tank filled as much as possible to prevent that moisture from getting in there. Other corrosion is rust, sand, you name it.
Right. On the E85 pumps, I mean, we are making pumps that can work in both an E10 or, straight gasoline, no alcohol. You can buy that and pay a little extra to pump at some fuel suppliers, but mostly it's going to be E10, and if you get the flex fuel vehicle, you have the E85. What happens to a pump that is not qualified for E85 and the customer buys it anyways because it's cheaper? And they don't know any better. They don't know a yellow gas cap means you do that. A black gas cap means no E85. They put it in anyways. And I know some of you listening and watching this, it's like, well, we usually get those in on a wrecker. It doesn't run. But what if they top the fuel off, occasionally use this? What effect does that have on the fuel system and specifically the fuel pump?
Well, at Delphi, we do validate to E20 all of our fuel pumps since like the 1980s. So we do testing at E20, which is 10% more than what you get at the pump.
Yeah.
But what will happen is the internal components of the fuel pump, the rail, the injectors, in order to use E85 fuel, you have to have special material inside the pump. What it'll basically do is shorten the life of the fuel pump. If you take a gas pump that's built for gas engines only, and you run it at E25, let's say, it's going to shorten the life eventually.
So how long can we expect a pump to run that's not flex fuel, but they're putting that in there anyways?
If they were to put flex fuel in an E10 application, it could possibly shorten the life by 4 times.
Wow.
If you look at the curves compared to the material we use for E85 versus the material we use on the commutator and the pump for gas, you'll see the curves for durability are, they crash.
And if you're expecting, 10, 20 years life of a vehicle for a
Right.
fuel pump, it's not being murdered, it's just going to die a natural death. It's just old, like, a drive shaft wears out or whatever. And we start reducing it by a factor of 4. We're looking at a pump that dies every couple of years, and that's going to be an issue that customers are going to complain about. Even though most repair shops are not doing a 3 and 36, they're doing maybe a 2 and 24 or something like that, or 12 and 12 with their repair warranties. It's still a bitter pill to swallow for a lot of customers. Hey, I just put one of these on 2 years ago. And we need to find out more about what they're using. What do you recommend for testing for fuel quantity, or quality, I should say, and specifically looking for E85?
I know there's some alcohol test kits out there that people can use, but a simple test is to take a known amount of water in a graduated cylinder, add the same amount of fuel, and see where the water versus the fuel separate at. That'll tell you what your alcohol content
Yeah, if
is.
there's no alcohol, they should be right in the middle.
It should be right in the
You
middle.
have half and half, and the
If
water.
you've got a 10% E10, you should be able to measure it.
Exactly. So that's an important thing. Back to the electrical side of fuel pumps. A lot of technicians that are a little higher end, and they like scopes more than just looking for an open plug wire. They're hooking a scope up with an amp clamp, and they're current ramping fuel pumps. My question to you is, how accurate is that? And do you see, when you look at bad pumps, returned, do you see the like we have in the illustration here, do you see the bad looking pattern, the classic? And if so, what are we looking at exactly?
You can look at the, excuse me, you can look at the amperage of a pump, but it won't really tell you for sure if the pump is bad. I've seen pumps that can generate 62 psi pressure, but their flow is low. But if I look at the amperage on my test stand, it's within spec. But what's happening is the contamination is actually affected the pumping section, but the motor is still running at the same voltage and amperage. So, but the flow on my flow column, it drops dramatically.
Electrically, we look great.
Electrically, we can look really good, and that's why amperage isn't always the best way. You still want to do a
Yes.
voltage drop test if you have a real
Right,
low pressure or
right.
no start. But it's not the way to
See,
really
we're
correct.
feeding it with voltage,
Yep.
and also look at the pressure. And look at the pressure when you initially do a tip in, and it should actually pop up a bit, should
Pop
never
up a
drop
bit,
down,
and
and even more importantly,
Yeah.
stay down.
Stay down.
So I know a lot of guys, and I don't recommend this because it could be a bit of a safety hazard. And if you did do this, and actually a fire extinguisher should accompany you on a road test. But I've seen guys actually duct tape a fuel pressure gauge to the windshield and watch it under a load. Better than that, you should probably invest, and they're not that much money. They've come down in price in recent years, but look at a fuel volume tester that not only has the round gauge for PSI, but also gives you a volume of how much we're actually getting out of that pump with more of a graduated, kind of like one of those, I want to call it a carb stick, but what was it we called it a minute ago?
Column.
Yeah, a column, like column of water pressure. So a lot of the tools out there on the market, they're out there. Mighty Vac's got one, and there's others that have been out there even longer than that. So look into those and add that to your diagnostic arsenal rather than to do something a little more sketchy like duct taping a fuel pump to your windshield. But it's very important we know what the volume that engine's getting, not just pressure. So any other things you can give as some advice to our listeners today?
Biggest thing that we're seeing on warranty parts is you want to clean that fuel tank before you put a new pump in it. Purge of it all the old fuel. Buy our, I think our cleaning kit's coming out here shortly if it's not already available. I think
Right.
it's FCO1 is our catalog number.
Yes, exactly.
But clean the tank and add fresh fuel, known good fuel. Don't put the old fuel back in it. And then if you put the new pump in and you're still not getting the results you want, do the voltage drop test. Do all the stuff on. But number one thing always, when a car comes into your shop with a complaint, you think it's fuel, do like the doctor does. Take the pressure. Take the pressure, see where you're at,
Exactly.
and then move forward.
Something I want to add in there, you just touched the nerve about checking the pressure like a doctor. You know, diagnostics is great to do. If you can't get paid for it, you're not going to do it. So I recommend thinking like the doctor. The doctor doesn't call it diagnostics. The doctor says, we'll run some tests. And sometimes they'll define, maybe they'll give a little bit, we're going to check your blood, we're going to check your cholesterol, either good cholesterol, bad cholesterol, red count, blue, white counts, and so forth. And when you get that test, and the doctor goes back through there, usually a good doctor, a good physician will sit down with you, explain what some of these tests are. And naturally, you're the consumer, the patient. Maybe a lot of it's going to go in one ear out the other. But the point is, you've seen something tangible that the doctor did for your benefit, and they took the time to explain it. I want to encourage you, if you have anything to do with the front end of your repair shop, if you're the owner, service manager, service advisors, even techs, to give advice to service advisors, is to write up a worksheet. Put your company logo on the top of it and make it consistent. Have your techs, whenever they do a fuel system test, they have, what would you want to include? Voltage drop,
Voltage drop, pressure check.
Pressure.
One thing I forgot to add too, if the car has an inline fuel filter, change it. I mean, for the $10, $15, $20, tell your customer I'm preventing a comeback for you, because if that new pump is pushing against a restricted fuel filter, it puts excess pressure and amperage on the pump, and it'll eventually wear it out faster too.
Would you include maybe checking it for alcohol? So those things could be on the list.
Well, if they're purging the tank and cleaning it and adding fresh fuel, that should be out of the equation. But if you're not taking the fuel out, say most guys I've ever done pumps for, they bring it in full, thinking that's going to help their fuel pump.
Murphy's Law. Yeah.
And if you don't have the capacity to empty 34 gallons out of your Chevy Silverado, then yeah, definitely do the fuel alcohol test.
Yeah.
And if you don't have the test kit, a simple backyard trick, we call it, is a graduated cylinder. Got a science class, kid in science class, you can get one.
Exactly. And on the lines of 34 gallons of fuel, please use safety at all times when you're working on a vehicle. It's nothing to be winked at. It's something that's going to keep you alive, keep you healthy, and keep your shop from burning down. So a fuel caddy, not just a few jerry cans to put the fuel in, but actually an approved safety fuel caddy where you can pump the fuel out and pump it back in. And adding to the rest of those tips where you can have something tangible, and that worksheet I talked about, as you sell the worksheet, we think we need to do a fuel system test. You might also add some scan tool PIDs, like fuel trim. That's one way of knowing that you've got low fuel pressure. Is the fuel trim high? Are we adding a lot of fuel to compensate for low pressure? So add those things into a chart. Most of you know exactly what I'm talking about. It's just articulating it, taking time to type it up onto a form, and then printing a few out. And when you sell the test, you have something tangible to show. And when you do the test, and we get the results that Dave's talking about, we have something to write down and show the customer this is what we did. So these are things to help you on the business side, because we can talk all day long about all the nuts and bolts and the engineering tips and tricks, but if we can't get the customers to buy into it, then we've lost the battle. Finally, I want to ask you about capitation, because you kind of mentioned restrictions and the filter up front and after the pump. What about that sock, that strainer in the tank?
Strainer in the tank.
There?
I've seen some where you get the capitation where the pressure goes up, goes down, especially at real low fuel handling conditions, or if the strainer's plugged and it's trying to get fuel through the active fill on our modules especially. We have a passive fill too, but on some of the higher demand engines that need more volume, it's not going to keep up, and sometimes it could be just as simple as, especially when you replace some of the FE pumps, you got to put a new strainer on it, and some of those things.
Now, most of the time when the vehicle runs out of fuel, we've got electronics that, no more RPMs, no more fuel pump operation, all right? So the fuel pump relay turns off and all is fine. However, I have one little case study the technician shared with me where they were using their scan tool to relentlessly trigger the fuel pump, and they were having cavitation problems. Dave, how long would you guess does a fuel pump last when it's out of fuel?
Well, the brushes will wear faster because fuel actually lubricates it. The brushes versus the commutator. I couldn't give you an exact time, but let's just say it's going to shorten the life if it keeps cavitating.
Exactly.
Because you're basically rubbing your carbon brushes on the commutator, and eventually it's going to start wearing and scoring.
This particular case study, the gentleman had a shop full of cars and couldn't, the customer's in a big hurry, couldn't get to a free lift. So like a lot of us do, we work outside. And a nice day, you're out there next to the shop, you roll your toolbox out. In this particular case, it was the driveway of the shop was on a bit of an incline. And so they chalked the tires, of course, for safety reasons. Jacked the car up with a couple of big floor jacks and put some stands underneath it, and went on the side of jacking up the back of the vehicle a little higher than the front. We're already on an incline. So now we had quite an incline for the whole vehicle. Well, we're on safety stands, so we're okay there. But when the fuel was drained out of the tank, the particular vehicle had a drain plug in the bottom actually, and emptied the tank out, which it had 5 or 6 gallons, they told me, which should be fine, right? When they put the new fuel pump in, which is towards the back of the tank on this particular application, and poured the fuel from the vehicle back in, which you're suggesting fresh fuel, and not that fuel that you drained out, but they put 5 gallons in nonetheless that they pulled out, thinking that's plenty of fuel, and it wouldn't run. So they relentlessly hit it with their scan tool to turn the fuel pump on and do a lot of the things you were talking about. Check for pressure, check for voltage drops. They even put an amp clamp on and current ramped it with their lap scope. And they got so busy doing diagnostics of why this engine wouldn't run and they had low fuel pressure with a brand new fuel pump that they actually damaged the brand new fuel pump and just assumed, well, it's a bad pump. So they got a second pump and the same story. The vehicle was back in. Obviously, it had the same 5 gallons to donate to the jerry can they were using. It didn't have the fuel caddy, and repeated the same thing all over again. I bet you've never heard of such a technician doing such a thing. It does happen, right?
It does happen. Yeah.
We get busy and we get flustered and we make the same mistakes twice. So don't assume because you got 5 gallons of fuel, that's enough if you're on an incline in certain applications. And as you mentioned, speaking of certain applications, you mentioned earlier, before we got on recording here, we were just chatting, that different pump manufacturers use different type designs for the same application. And you may see a known good pump for a given application that would run wonderful and do a good job for years, that only uses 6 amps, another design, nothing wrong with the design, same application would last years and years if it's not murdered with contamination and so forth, or voltage drops, running 9 or 10 amps.
Right. There are some OE pumps out there that will run 9 to 10 amps and do the same function as others at 6 amps. Same pressure, flow. It's due to the internal components of the pump, how it's built and how it's manufactured.
So in that regard, we're basically talking about a scenario where looking at the current draw, in a lot of manuals, it talks about if the current draw is lower than normal, you go this route, higher than normal, you go another route. It's relative to the pump design.
Could be.
So we want to make sure that we're not having apples and oranges, that we know what a known good pump from that manufacturer draws in that particular application, and then maybe you can use the amount of current in your diagnostics. But if you don't know that number, we better just rely on pressure and looking for good feed of voltage under load at the pump. Well, Dave, thank you so much for sharing a wealth of information. An engineer is a car guy. That's a great thing. I hope you've learned as much today as I have. If for more information, please visit DelphiAutoparts.com. And if you have any questions or comments, please forward them our way at delphi.podcast@delphi.com. On behalf of Delphi and Dave Kinney, I'm Dave Hobbs for Delphi Product Service Solutions. Thank you for watching the Delphi Auto Parts Cast.